Hello, good morning all. In today's sessions, we'll discuss about gears and gear trends. So basically, we have different power transmission systems which are available to transfer the power from one component to other component. We are using belt or rope drives. If we have large center distance between the shafts, then we can go with this belt and rope drive. And then second option, we have chain drive. If suppose if we have medium center distance between the shaft, then we can go with the chain drive. And third part, we have gear drive. When the small center distance between the shaft is available, at that time people can use this gear drive to transmit the power between two shafts. Okay. Now just look at the arrangement. Basically, I'm sharing this part where we have these two drive systems. Okay, so we have gear, input gear and output gear, and power is transferred with the help of this gear tooth between these two components. Now, how that gears are engaged to each other? These gears are basically engaged with the help of some tooths. Okay, now there are different types of tooth. We have involute type of tooth, cycler type of tooth. Okay, so if the tooths are straight, then that tooths are known as involute tooth where pressure angle is constant. And if tooths are curvilinear, then that tooths are known as cycloidal tooth where we are varying the pressure angle. Okay. Now, uh, how that component is transferring the force or motion, or you can say torque between the shaft. These tooths are basically engaged at each point. Okay, and at a time, mostly two tooths are in engaged position. So one tooth will going to engage and second will going to disengage during the motion transmission. And hence, power or torque will get transferred from input shaft to output shaft. Okay, this is the arrangement of tooth where we can transferring the torque or we can say motion between the shaft. Okay. Now next, what are the advantages of this gear drive? So we have discussed this. We have chain drive, belt drive. Still, these gear drives are very important to transfer large amount of power or torque, we can say. So these are the following advantages. We have it transmit large velocity ratio, then large power. It has high efficiency. Okay, it is reliable source. And we can say the important issue with this is it requires special tools. Okay, and if there's a failure in tools, then total system may get back. That are the disadvantage of this gear system. Now just look at the arrangement of classification of this wheels. Okay, or you can say gear shafts. So first part is if suppose if shafts are parallel to each other. Okay, this is the arrangement where we are talking about engagement of gears. Okay, so when shafts are parallel to each other, we have again spur gear. So teeth are parallel to the axis of shaft, so motion will get transferred from input shaft to output shaft. So this is the first case we are talking about the classification of this wheel when axis of shafts are parallel to each other. So in this first part, we have spur gear, we have internal gear, helical gears are there, herringbone gears are there. In all these cases, we are using parallel shaft position whenever we are mounting these gears on any gearbox. Okay, so this is the first part. Then we have second, if shafts are intersecting to each other. That means if axis of shafts are perpendicular to each other, then we have combinations of spiral bevel gear. Okay, where again these two axes are perpendicular to each other. Basically, this kind of arrangement is used in differential gearbox, where we have this bevel pinion and bevel gear, which is used to transfer power from propeller shaft to that wheels, axle of wheels, rear axle of wheels. Okay. Now again, this is the straight bevel gears. This is the combinations. Okay, and just look at the arrangement of teeth. Okay, so teeth are inclined to each other, and the axis of shafts are intersecting to each other. That means these axes are perpendicular to each other. Okay. Then next, suppose say if you have non-intersecting and non-parallel axis, then at that time we have this cross helical bone gear. Then we have worm and worm wheel gear. Okay, so this part is known as worm. This is worm wheel. Okay, so this worm is driving to that worm wheel. Again, it has specific motion. Either it can rotate in clockwise direction, but whenever we are using these combinations of worm and worm wheel, it has fixed structure. Okay, so this movement will get locked, and there will not be any irreversible motion between worm and worm wheel. We have only single directional definite movement which we can achieve with the help of these combinations of worm and wormhole. Okay, so basically this arrangement is used in that suppose if you want to use this gearbox to open the doors of dams, at that time you can use worm and wormhole type arrangement. Okay, so this is about third part where we are talking about axes are non-intersecting to each other. At the same time, the axis of shafts are non-parallel to each other. Okay, then suppose if you want to transfer low velocity ratio, suppose if we have medium velocity, high velocity, okay, at that time, again, we have these combinations of gears, where we're talking about external gearing, internal gearing, rack and pinion. Okay, so this rack and pinion arrangement is used in steering mechanism. Okay, and this internal gears, basically whenever we are designing that gear train, epicyclic gear train, at that time we can use these combinations of planet and internal gear train to transfer the motion from input shaft to output shaft. Okay, now next, so this is all about, you can define the gears. Now next part is terminology of spur gear. Okay. Now basically, if you look at the single combinations of a gear, what we have a single tooth. Okay, and this is the pair of tooth which is given. Let's say this is a pair of tooth of pinion which is engaging with second tooth of gear. Okay, so just look at the arrangement of this spur gear. So what we have this circular pitch. Okay, this distance between these two tooth surfaces is known as circular pitch. Then we have topmost distance, that is known as addendum. Okay, then this base part is available which is below that pitch circle distance, that is known as dedendum. Then this part is known as face width of that tooth. Okay, so upper part is addendum, lower is dedendum, and this is the face width. Then next we have this tooth thickness of that uh, gear part. Then this upper portion of that tooth is known as face. Lower portion of that tooth is known as flank part. Then overall engagement of tooth from top to that base circle is known as working depth of tooth surface. Okay. Then we are providing clearance to avoid the jamming or locking of gear. There is a clearance which is provided on that base surface of tooth. So that part is clearance. So, and this is a top line surface. Okay. So we'll discuss one by one how to define all this part. So pressure angle, basically, teeth are gear teeth are defined with the help of pressure angle. Now, what is the pressure angle? It is the angle between common normal and tangential drawn at tooth surface that define the pressure angle. The range of, normally the pressure angle range for this gear surface is 14.5 degree to 20 degree. Okay. Then next, circular pitch. Circular pitch is nothing but it is the distance measured on the circumference of each circle from point of one tooth to the corresponding point of next tooth. So that distance is known as circular pitch. I will define with the help of diameter and number of teeth. So it is pi d upon t. Okay. Now, if suppose if you want to calculate, suppose two gears are in mixing position, and if you want to find out the dimensions of that gear, so we are mentioning that by considering the equal pitch of the gear, we can equate pi d1 upon t1 is equal to pi d2 upon t2. So that we get correlation between two diameters of the gear and pinion. So it will be t1 upon d2 is equal to t1 upon t2. So this is all about the part. So this part is known as a circular pitch. We are taking corresponding distance between the tooth surface. And this part is nothing but your circular pitch of a gear. Pressure angle is nothing but it is the angle between tangential surface, that is tangential drawn to the surface of tooth, and normal line which is drawn to the surface of tooth. So that angle is known as a pressure angle. Okay. So this is the two part. Then next, what we have, a diametral pitch. Okay, so it is the ratio of number of teeth upon diameter of gear, that is known as the diametral pitch. Then next module, so it is the ratio of piece circle diameter upon the diameter upon teeth, that is known as module. Then we have backlash, so it is the difference between tooth space and tooth thickness. Okay, that is measured along the piece circle, that is known as a backlash. Okay, so normally this backlash value is 0. Okay, in actual practice, but in some cases we are taking that we are plotting some value of backlash, that is 0.0157 times module toward the jamming of tooth surface. Okay. Now how we can calculate the center distance? So center distance is nothing but if you are taking teeth on pinion plus teeth on gear into circular pitch upon 2 pi, or you can say addition of uh, teeth on pinion plus teeth on gear upon 2 times diametral pitch, that will define the center distance. Then we have base circle diameter, that is pitch diameter into cos phi. Okay. Now next is addendum. So addendum is 1 upon diametral pitch. Suppose if you want to calculate the addendum, then it is 1.75. Because this distance is given, there is a correlation between module and addendum. That will be 1.157 times diametral pitch. Then we have working depth, this 2 upon diametral pitch, 0.6366 into circular pitch, and we have hole depth, that is 2.157 times a diametral pitch. Okay. So this is all about how you can define addendum, dedendum, working depth. Then we have clearance part. Clearance is given 0.157 times upon diametral pitch, that is 0.05 into circular pitch. Then we have outside diameter, So teeth plus 2 upon diameter pitch, that is circular pitch upon pi. And again, we can calculate diameter pitch by considering teeth plus 2 upon outside diameter. So by putting all these values, one can find out the basic details related to dimensions of gears. Okay. So this is all about how we can determine the dimensions of gears. This will stop here. Thank you all.